In this video, we will solve the problem from the Sadiko textbooks. Find the magnetic field intensity H bar at 005 from the side 1 of the triangle given. So, if you observe the triangle, the side 1 is this one. That means the current is passing from 0 to 2 on the x-axis. That current is 10 amperes current. And our observation point is 005. So, given data I will write here. OP is 005. That means it is on the z-axis. And current value I is nothing but 10 amperes that is passing along the positive x-axis from 0 to 2. So we need x-axis and we need z-axis also, but there is no requirement of the y-axis. So you can redraw the diagram by involving z and x-axis. So I am taking like this. It is x-axis, it is z-axis. So current is passing from 0 to 2. That is 10 amperes current. And observation point is at 005. 005. This is our OP. Okay. So this is the current passing from 0 to 2. So the diagram is looking like our derivation part only. Conductor is vertically available, but it is not on the z-axis, it is on the x-axis. But whatever it may be, we can assume this is the case where the observation point is below the conductor. But here, it is not below the lower end of the conductor, it is along with the lower end of the conductor. So careful observation is required. That is, the perpendicular and line joining lower end and observation point are same. Perpendicular we are defining like from the observation point we have to draw the perpendicular to the axis of the conductor. Okay, so this itself is the this itself is the perpendicular, and also it is the line joining the observation point and lower end of the conductor. So alpha 1 we have defined in between these two only. Okay, so now because these two lines are same, alpha 1 is 0. So in the formula generally we are dealing with the sine functions. So sine alpha 1 is equal to 0. Directly we can write that one. Okay, then alpha 2. Alpha 2 is the line which is in between the perpendicular and the line joining the observation point and upper end of the conductor. So this is the alpha 2. And we know that this is phi, perpendicular distance is phi, and this length is 2. So that easily we can write this hypotenuse, that is root of 25 plus 4, that is equal to root 29. So how to define sin alpha 2? Sin alpha 2 is equal to opposite is 2 and hypotenuse is root 29. And I value they have given 10 amperes, that is available with us. And sin I by 4 pi rho according to the formula. So rho is also phi. I am writing here rho is equal to phi. Sin alpha 2 minus sin alpha 1 they can write. But main thing is here about getting the phi cap. Phi cap is given by L cap cross rho cap. L cap should be given according to the current direction. Current is passing in the positive x direction. So it is x cap. It is in cross product with the rho cap. Rho cap means away from the conductor we have to take towards the observation point. That is nothing but along the z-axis. So it is equal to minus y direction we'll get. So finally, h bar is equal to, I can use the formula I by 4 pi rho sin alpha 2 minus sin alpha 1 or plus sin alpha 1 also you can take, there is no problem for that one because here alpha 1 is 0 and phi cap. So it is equal to I is 10 amperes by 4 pi rho is 5 and sin alpha 2 we got 2 by root 29 minus 0 and it is minus y cap. Okay, so what we can write? It is 20, this is 20. So finally we got 1 by pi root 29 minus y cap. Okay, so just I will calculate this one. 1 by so I got it is 59 minus 59.1 milli amperes per meters and into y cap is there. Okay, and here one more thing is answer is over. We can estimate the direction directly using the right hand thumb rule. Using right hand thumb rule, direction of H bar can be given. How? You have to keep our right hand thumb in the direction of the current. Okay, then we have to hold the conductor in our this right hand by keeping the thumb in the current direction. Then in which direction this particular curl is available, in that particular direction magnetic field will be there at the observation point. So first of all, according to right-handed coordinate system, if this is the z-axis, this is the x-axis. Okay, so y-axis is coming out of the plane. So here dot y I am taking. So positive y-axis is coming out of the plane. So if you use the right hand thumb, if you use the right hand thumb, how to keep that particular thumb like this, I am just drawing. This is the this is my right hand thumb. I am keeping in the current direction. Then these fingers are going into the page at the observation point. My right hand is going into the screen at the observation point. Into the screen is nothing but negative y direction only. That is what we got here. The phi direction you can see negative y direction. Okay, thank you.